Have you ever been walking somewhere, maybe miles from the coast, and found a seashell? And you just stop and think, wait, how in the world did you get here? Well, today we're going to dive into a pretty wild theory by an author named Abdullah Boufim that has a very unique answer for why our planet's coastlines seem to have shifted so much over the ages.
So here's the plan. We're going to start with the big mystery that this whole idea is trying to solve. Then we'll look at how the first seas might have been born. From there, we'll get to the core idea, a planet that's actually growing, and see how that could make the seas retreat. And finally, we'll tackle the opposite question. What about when the sea seems to be attacking the land? All right, let's start with the puzzle that got this whole ball rolling in the first place, the mystery of our ancient coasts.
This is the fundamental question, right? It's a geological riddle people have noticed forever. You see clear signs of ocean life way, way inland, which obviously suggests the water used to be somewhere completely different. But the big question has always been, why? What happened? And look, we're not just talking about a couple of random shells here. We're talking about huge coastal plains, entire landscapes that have all the telltale signs of once being underwater. The evidence is pretty clear. These were ancient seabeds. So the mystery isn't just about a few misplaced shells. It's about, where did a whole sea go? Now, to understand why the sea might be pulling back, the author says we have to rewind all the way to the beginning, to the birth of the very first seas. The theory kicks off with this really unique concept called the first prostration of the sun. Now, this term describes the end of the sun's very first cosmic cycle. And at this point in history, the Earth is imagined as being totally frozen, just wrapped in these incredibly thick layers of ice. So here's how it apparently went down. First, the sun enters a new phase, and all that ice just melts. Now, can you imagine the colossal weight of that ice suddenly disappearing? The theory goes that this sudden release of pressure, plus some violent reactions in the planet's core, literally caused the Earth's crust to crack. And finally, all that meltwater poured into these new, shallow cracks, and boom, the world's first seas were born. Okay, so that's the origin story for the seas. But it doesn't explain why they would retreat. And that brings us to the absolute heart of this theory, the engine that's driving everything else. So here it is, the main event. The theory argues that our planet isn't static, not at all. It's actually in a state of continuous growth. The idea is that these crazy, ongoing reactions deep down in the Earth's core are causing the entire planet to expand, to literally get bigger and bigger over time. And this chart gives you the perfect before and after picture. In the past, you've got a smaller planet with those original shallow seas, meaning the water spread way out over the land. But today, you've got a larger planet, and that growth has carved out deeper and wider ocean basins, which in turn has pulled the coastal line back. So let's connect those dots. How exactly does a growing planet make the sea pull back from the shore? Let's break down the mechanics. Okay, so here's the chain reaction. As the Earth expands, its crust has to stretch. The theory says the crust rips open at its weakest spots, which just happen to be the ocean floors. This constant tearing makes the sea basins both deeper and wider. Think of it like this. The container holding all the ocean water keeps getting bigger, so it can hold a lot more water. To fill up all that new space, the water naturally has to pull back from the coastlines. And the author believes this expansion effect is unbelievably powerful. This quote makes a really mind-bending point. Even if all the polar ice melted, which we always hear would cause catastrophic flooding, the sea level might not actually rise. Why? Because the ocean basins could be expanding at the same time, creating more than enough room for all that extra water. What's really cool is that the theory breaks down sea retreat into two different types. On one hand, you have the gradual retreat. That's caused by the slow, constant growth of the Earth, and it's the process that creates those vast coastal plains over millions of years. But on the other hand, you have sudden retreat. This happens when a huge crack abruptly rips open on the seabed. It causes a violent but temporary retreat of water from the shore, which we now recognize as the terrifying warning sign of an incoming tsunami. Of course, you might be thinking, hold on, not every coast is retreating. We all know about places where the sea seems to be on the attack, swallowing up the land. So, how does this model explain that? This is the big counterargument, isn't it? If the ocean basins are getting bigger, then why isn't all sea level dropping? What's going on in the places where the exact opposite is happening?
Well, the theory says these are just localized exceptions to the global rule. And the explanation is pretty straightforward. In these specific spots, underwater volcanoes are actively growing up from the seafloor. As they get bigger and bigger, they take up more space, pushing water out of the way and forcing the local sea level to rise.
The author uses a really simple but powerful analogy to make it crystal clear. It's just like dropping a big rock into a full glass of water. The volume of the rock displaces the water, and the level has to rise. In this case, the growing underwater volcano, well, that's the rock. Makes perfect sense, right?
All right, let's pull this all together. Here are the 4 cornerstones of this whole idea. 1. The Earth is constantly growing from the inside out. 2. This growth makes the oceans bigger and deeper, causing the sea to retreat over the long term. 3. Sudden cracks in the ocean floor are what caused tsunamis. And 4. When you see the sea level rising in one spot, it's because of underwater volcanoes displacing the water.
So whether you buy this theory or not, it paints a picture of our planet as this incredibly dynamic, living thing, not just a static rock in space. And it leaves us with one last massive question to think about. If our world is constantly reshaping itself, what on earth will our continents and coastlines look like millions of years from now?